From the Autoline studios, here is your host, John McElroy.
I want to thank you all for joining us on Autoline this week. The topic today is going to be all about cybersecurity in cars. How do you keep those hackers out? Well, we've got three experts that are going to fill in all the details, including Erika Anden with a company called Silent Cyber, Jeff Massimilla, who's the Chief Product Cybersecurity Officer at General Motors, and Egil Juliussen with the consultancy IHS Automotive. I want to thank you all for joining us on Autoline this week.
Thank you.
Thank you. Jeff, let me start with you. Recently we saw this hack that got headlines all over the world. There was a reporter from Wired magazine and a Jeep Cherokee, and a couple of hackers were able to get into this thing remotely, and boy, that set off all kinds of talk. How serious is this, though, really? I mean, how much do we have to worry about it? And I know I'm asking the Chief Cybersecurity Officer at General Motors this question, but put it in perspective.
Yeah, no, I think it's a very serious topic, John. You know, there's been a lot of research here recently on white hat researchers kind of performing hacking events in vehicles with vehicle connected systems. This is something that isn't going to go away. This is something that, the auto industry, and I'd say it's, not just the auto industry, but the broader, world is fighting this challenge of cybersecurity and different hacking techniques and ways to mitigate those risks. And, it's something that each of the companies need to take on and take it on head on.
Egil, how do you see it?
Yeah, no, it's the good news is that in terms of somebody really hacking a car, it's very unlikely. And the reason is it takes so much knowledge, and there's really not a business model for hackers to earn money, because that's really what they want to do. The only one is really stealing the car, and they can do that with the key fobs better than they can in the telematic system. But the bad news long term is that the knowledge is going to increase fairly rapidly, and the systems in the car are becoming more similar using hardware and software platforms, so it will be easier in the future. But the good news again is that auto industry is now taking this serious. And what we want to happen is that they invest enough that it's not going to be a serious problem anytime soon or ever.
And Erika, how do you see it?
I also see it as a serious problem, and I think that we should look at what happened with the Chrysler hack with responsible disclosure. We should look at how we do that in the future, because I think we're headed down kind of into a game of whack-a-mole with hackers, and we don't want to play that. We want to dictate how this goes down.
Well, do you think the guys who hacked into the Jeep were being responsible? I see them as glory hounds.
I think it maybe wasn't the most responsible form of disclosure, put it that way. I think that when you are responsible, you probably don't want to give out as much information as they did, but at the same time, they were looking to get the reaction that they got, which was they wanted to get the attention of the auto industry. They got the attention of the auto industry. Was it the right way to do it? That kind of remains to be seen in the long run. Are they going to motivate other people to do it the same way? Potentially. And that's really the risk. And
Jeff, you're at a car company. Did they get the attention? I mean, General Motors had the foresight to appoint you as the Chief Cybersecurity Officer for product. I mean, clearly, even at a board level, GM was thinking about this some time ago.
Absolutely, and obviously before the Chrysler research, and responsible disclosure is a big part of this. But how they get the attention is what's challenging here. I think a lot of companies and every industry are not necessarily set up to interact with researchers in the right way, and you got to have that method of interacting with them so that they can responsibly disclose and you can work with them. But I think oftentimes they'll turn to media if they don't have the way to get that information to you. At the same time, though, as you said, from a board perspective at General Motors, I mean, this is an important priority, a high priority in our company. The safety and security of our customers is our highest priority. So, from that perspective, appointing my role and creating my organization to perform the end-to-end security for our customers is paramount.
But, on the other hand, if you look at what was done in 2009 and 2010 by University of California, San Diego, and University of Washington, they did similar things, maybe not as dramatic. And, they got a lot of attention and information spread around, but it didn't create this kind of a press coverage and which hit the auto industry and so on. So they got the right attention, and I think looking back, we're going to be happy that they got it.
Why do you say that? Because you're right.
Because the industry is now really taking it seriously, investing even more, and they were starting to invest in R&D, and there's going to be companies that are bringing out products. So the snowball is rolling and it's getting much bigger. So the momentum for getting cybersecurity is much stronger now than it was 3 months ago.
Erika, you see that the industry is now more serious after this very...
It seems like the response has changed since the hack. But I feel like the industry was getting very serious about it even before the hack. There was definitely already a response in the industry to companies like mine in terms of kind of getting on board that train, dealing with cybersecurity issues, mitigating vulnerabilities, and kind of trying to deal with the problem in a responsible way. I think this brought it out in a different way. I think obviously there's going to be more action taken. But it's creating another type of problem where there's going to be an expectation that companies can deal with these problems immediately. And that's not possible. And it takes time to fix these problems. And when you have a group of people who find bugs and go out to the media with them rather than going to the company, the expectation on the company is that they can turn around in a dime and fix that right away. And they can't. I mean, in some cases, it can take years.
Egil, though, we saw in the case of the Chrysler hack that the company was aware of this vulnerability 18 months before the hack. Yeah. And over in Europe, the Volkswagen Group, including Bentley and Porsche, have a real problem with theft. They sat on it for 18 months. So maybe we do need somebody to light a fire under these companies.
There's a complacency out there saying, and it's true for all the industry, it's not going to happen to me. But it does. But the other thing with the Chrysler, if you look at it, you do a simple back-of-the-envelope calculation, 1.4 million cars. Let's just assume $100 per car. That's $140 million. That's real money, even for the auto industry. So they could have spent $1 million early on and, put into cybersecurity, and it would have been a better solution. So it shows the return on investment of doing it, which we didn't have before. So for that reason, there are many companies then that are going to take it more serious.
That was actually the huge positive, I would say, with the Chrysler hack, is that we got a sense of how much it costs to have a recall
to ignore
like this.
it.
Yeah, because we never really had a cyber recall before. This was the first major cyber recall, and now we know how much it costs. Yeah. So that kind of changes the game a bit.
Jeff, I'm wondering what you're doing to protect GM cars from this standpoint. And you know this better than I do. You can't stop these hackers. The Pentagon's been hacked. President Obama's personal email account has been hacked. And I got to believe some of the best anti-hacker security was on those systems. What do you do when it comes to cars?
Yeah, I think it was pointed out, how difficult it was, and we talked. I mean, I think the researchers you referenced the University of California and Washington papers, and the length of time that research took place, the length of time the Chrysler research took place. This is complicated. This is very complicated research to actually get this stuff done. That being said, and we referenced it already, it's also then complicated to address it. But there's a lot of things that you can do to address this type of activity and to protect yourself. It's very similar. I can almost draw a lot of parallels to IT security. I mean, you can't take IT security and put it on a car necessarily, but there's a lot of the same principles that apply. And then just knowing if someone's in your system, being able to detect and monitor your own system, and then really it's your response capability. I mean, like you said, if there's unlimited resources, money, and talent, someone's going to find a way in. We got to be right 100% of the time. They got to be right one time. At the same time, we just have to be able to respond when that one time occurs.
But it's actually relatively, from a concept system level, it's relatively simple. You got to do two things. You got to have perimeter security, which checks everything coming in and out of the car, but then you say, okay, I cannot protect all of those, so somebody will break through. So then I got to have what I call operational security, which means you got to have some system in the car that literally watches all the information flowing between the control units, and it's got to need a database of what's legal and what's not, and that's what's coming to the auto industry over time. And the whole idea is to make it expensive so the business model doesn't work, and then you got to improve it all the time, and it's never done.
And it's really, I'm sorry, that's really complicated. What you just said is, protecting, the entry points into a vehicle is one task that is very straightforward, I would say, and principles of how to do it. That whole ability to control everything that's going on. And once you're in the perimeter of the vehicle, I would actually argue that defensive measures in all the aspects of the vehicle, with some ability to detect and monitor if someone is, getting through your defensive measures, would be the appropriate way to approach it as well.
So what you're saying is just having a firewall isn't enough.
Not at all. Yeah, it's point security, right? I mean, defense in depth, defensive measures in layers is the I think the primary approach to cybersecurity.
But that kind of hardware security.
Yeah.
I think that kind of gets us to the root of the problem, which is that security needs to start in the design phase.
Absolutely.
Because it's right now the reason we're playing whack-a-mole and the reason we've ended up in this position is that now we have all of these vulnerabilities, and since the cars weren't designed necessarily always to be secure, because this hasn't really been a problem till recently. We need to go back to the drawing board now and design these kinds of systems from the very beginning.
But Erika, as you know, it takes this industry a minimum of 3 years to design a car. So you're talking about a solution.
I'm talking about a solution that's 3 years out. Yeah.
But you're saying that's what it's going to take.
But we should start that now, and then we might have to go back to those cars that are already on the road. I mean, we know that it's going to be a long-term liability, that those cars on the road right now, we're going to have to keep protecting them and ensuring that they are secure for years to come, as long as the lifetime of the vehicle. So it is good. This now is the time to go back to the drawing board and say, okay, every car from this moment forward needs to be as secure as it can be.
But it's interesting, it's coming at the same time that they're putting software over-the-air updates, and it needs very similar changes to the system architecture. So they're probably going to put in both at the same time.
Yeah.
Is that how you see it, Jeff?
Yeah, that is your response capability, right? You need to be able to protect the systems in defensive measures or layers, and then be able to respond through OTA, over-the-air software update capability. I think both those are critical. I also would say, though, if you start with the drawing board, you can absolutely design it right in. But I think that there's very, very tangible, actions that you can take in existing. And I think the research here recently showed that where maybe a firewall is left open with some ports left exposed, and you want to close down those ports. You don't want those things open sitting out there, because those are the places that when they get their hands on those modules and they reverse engineer, that is the first thing they see, and then they know their way into the vehicle.
So how do you handle what Erika just brought up, the legacy systems that are already out there?
Well, you basically got to do a check of existing telematic systems and connected car system. And the thing is that the average software guys in the auto industry, they don't have that skill. So you got to get somebody that worked with cybersecurity, and they need to check it. And then when they find it, then you go fix it. And literally, I think they're going to all do that. They're probably all doing it now, and they won't tell us what they're fixing, but they will.
Right.
Yeah, I think you're right. I think there's a common set of tools out there that can help you when you're developing the software. Obviously, at General Motors, we leverage external expertise. We have a team of internal experts. We leverage external expertise. We team up with third parties for testing capabilities and scanning capabilities. We collaborate with industry partners in defense and aerospace. There's a lot of help and a lot of knowledge and know-how out there. But I agree with you. It's a matter of understanding where you may have vulnerabilities today and then remediating the vulnerabilities. And that's a pretty straightforward action.
And they learn from that for future systems as well. Yeah.
Sure.
Erika, what Jeff is saying is got to be critically important. This is an industry problem, not just a General Motors or a whomever kind of a problem. Do you really see the industry getting together, collaborating, rather than just, say, an individual company collaborating with some other companies?
I'm not entirely sure that that's how the auto industry is set up on a whole, to collaborate in that way. So I see companies collaborating, they're collaborating with their suppliers, but collaborating between the various companies, I'm not seeing that, but that might actually be going on behind. There's some level, there's an ISAC that's being built right now.
Yeah, that's right.
That's the first
and
step.
That is the first step.
And explain, for those who have not heard of what an ISAC is.
Oh, goodness.
It's information sharing.
Yeah, information sharing.
Something or other.
Yeah.
Yeah, it's the idea of having one central place where you send all the information and you learn, and they alert you to when something happened with one OEM. They tell what they did in concept, at least, and then you look for that yourself.
Or
so
the
it's
suppliers as well.
Early warning system, essentially.
But I guess I would say that I think there is some more collaboration going on. The SAE has had a work group out there for a long period of time developing standards in this space. AutoSAR is another consortium out there developing how to secure communications within a car. There is a lot of collaboration. I think the ISAC is an important.
They need to have their things.
For sure, and the collaboration that their engagement allows in this space as well. So all key collaborations that help each individual automaker not have to maybe reinvent everything.
Southwest Research Institute, they have. So
it's starting to happen.
And
of course, this is in its infancy. I mean, 5 years ago, who would have thought that we'd be talking about this? Certainly I didn't. Maybe you guys all did, but...
I did a presentation on this 5 years ago and said, oh, this is very nice, but we don't have to worry about this.
Egil, what you said earlier was so interesting that there really has not been a malicious attack.
Yeah.
There's been these white hatters,
right,
some of which I will call glory hounds, out to make a name for themselves at DEF CON or whatever. Yeah. But you're saying that the bad guys really haven't attacked yet.
I mean, how are you going to earn money? That's because there's no credit cards or very few stored in there, so there's no financial reward. You think about these people want to earn money one way or another, and there's no business model. No, there are some coming, and actually the scary one is what's called ransomware that's being used in the PC industry, where they
explain that
they encrypt the data on your hard disk drive, and then if you have valuable data, you can't get to it. So for $300-400, they'll let you have it back. And so the equivalent of that is to disable a control system in the car. So it
turn it into a brick, as they say.
Exactly. And then, same thing. And that's the one model that worries me the most. And hopefully that doesn't happen, or the companies will get enough so it can't happen. And see, if you think, if somebody, a malicious nation would do that to thousands of cars, now you're talking about cyber warfare.
Yeah,
and that would be the most serious. And then you really don't need a business model. You're doing it to mess with a country, and so then that becomes very scary.
Jeff, is this one of the things that you guys do worry about? This bricking of cars for ransom?
Yeah. So there's a list that every company looks at that transcends the different types of attackers, we'll say, that are out there that you need to be worried about. And right now we're sitting up at the white hat and the researchers and. The next one down is really it's the business model for creating solutions. So that's kind of where we're at in this now is, testing companies and solutions companies coming out and creating opportunities to put things into the vehicles to solve the problem. But then the next is the criminalists who want to profit or benefit from it, and then obviously it transcends even further. But I think the goal of General Motors, I can say it, I think I can speak for the automakers as a whole, is that we get out in front of this. Now is the time to get out in front of this. White hat and research, that's a controlled environment, and we work well with the researchers, and we got to continue to work well with the researchers. But you don't want it to transcend that list any further before you have a nice, comprehensive solution in place.
They doing enough in that regard, Erika?
I think they're definitely moving in those directions. They're doing quite a bit, and obviously there's a lot of outside help available as well that is helping to push in that direction.
People
and needed.
Yeah,
the outside help is needed. Absolutely.
I talk to people who follow this, not like you guys, working in the field, and they go, "Why can't you just not have all these things connected together inside a car? Why don't you have some sort of air gap?"
Well, I think actually you can speak better to that.
You could do a whole other show on that one. I think the consumer, consumer wants to bring. Sorry, go ahead.
Yeah, no. Basically, what you want to do, what we call the infotainment, all the driver, exactly. You need to totally isolate that from the rest of the car,
and then it wouldn't provide any service that the customer wanted while they were driving the car.
Or you can make it read-only data in some way.
Yeah.
And at some point that can happen. Certainly, when we come to self-driving and driverless cars, then of course that's going to happen.
Well, and that's the security solution, right? So I mean, not disconnecting these systems from each other is not reasonable and would not make the customer happy.
Because you actually take capabilities away from the car.
Absolute capability away from the car. And autonomous driving and things where you're getting data from outside, and semi-autonomous controls rely on that data. So that being said, air gapping it wouldn't work, but putting the right controls in place, read-only permissions, things like that, those are the types of controls and solutions that need to be in place as that content comes into the car.
Erika, is it going to be software that provides this protection, hardware that does it, or what?
I wouldn't necessarily say software or hardware. I think it's going to be corrections within the existing firmware and the existing software in the vehicles that are going to provide the protections. We're probably not going to come in from the outside with a software solution that can protect a vehicle, although there are solutions like that are currently being built and may work actually quite well. these sort of anomalous signal detection systems do exist, and that could actually end up being a solution. But that's very difficult to perform that sort of detection.
It's really a layer of security, and it really starts with the microprocessor that has to have some built-in hardware that makes it easier to implement security. There are cryptography type hardware that makes it much quicker to do. And then the operating system has to have security, and then everything builds on that layer. And there's something called a hypervisor. That's a very small operating system at the bottom. Of course, when you start the car and the software boot up, that's the time they can slip in a way that it's hard to detect. So you need something at that lower level. And like he mentioned, AutoSAR, they're putting that in, and the auto industry will be doing that. So yeah, they're working on the layers of security that's needed.
I think it's throughout. I think it's throughout the vehicle. Yeah. It starts at the system design. You got to design it to be secure. You got to have security in mind when you design the system, a subsystem, a component, software, hardware, all the way down to the micro. Right? I mean, it is fundamental throughout. It's fundamental throughout.
And Jeff, what you said earlier is really one of the main ways to protect is to detect that someone has gotten into the car, and then kind of shove them in a corner and hold them there?
That's right. Yeah, and that's one of the, I think, the largest challenges that in a real-time environment like driving a vehicle, how to mitigate the risk or how to mitigate you found somebody in there. What do I do now? It's a challenge that the industry will face, and they'll have to answer some questions on that. But you take even other events that have gone on in maybe Sony or Target or others, right? If they would have had the ability to understand that someone is in the system and stop it faster than they did, they would have minimized the loss associated with it, and then could have cut the connection, remediated the problem, and then opened things back up. So that's a key part of it, because again, you'll never keep everybody out. You want to keep the majority out, and you want to give them layers to have to get through. And as they start to transcend those layers, and I know they're transcending those layers, then I can stop them.
But I got to believe some of the real smart black hatters are going to cover their tracks, so to speak, right?
That would, I mean, that is the sort of thing they would do. So, yeah.
So how do you even try to sniff out that somebody's in there?
Well, what we do is actually try to find the vulnerabilities that exist today. That is what my company does. And they approach it from a hacker perspective. So they actually try to find out what are the open doors in this vehicle, so to speak. How can we get into the system? And then once we're in, what can we do? How can we play around in here? What can happen? And it's a way of discovering, how far in can someone get in this vehicle, but detecting whether someone's been in the vehicle. That is not where we are just now, but we're working on that solution as well.
What I call the operation security, that's basically there are products out today that can do that, and it's to look at the messages flowing back. If there's a signal going to the brake coming from the infotainment unit, that's wrong. And so if you have a database of what's legal like that, then you can comprehend what's, like he's saying, that's what they want to do. You want to literally have a database of the legal stuff that can flow between there, and then anything that looks different, you're going to check it and send it back for inspection and find out if that's something illegal.
Cars are so hard to do in the first place, just to meet all the regulations. And like, Jeff, is all this cybersecurity work going to slow down product development?
No, I don't think so. I think the way we're approaching it in General Motors is we're looking at the vehicle development process, and cybersecurity is being injected in every stage of vehicle development process. So what that says is, instead of at the end, now, what you're talking about, red teaming and vulnerability testing, it's extremely important. We do those activities obviously as well, but if you don't start up front and you get yourself engaged in the entire vehicle development process, you would slow it down at the end, because at the end you would say, I have 10 things I have to fix and we aren't ready to go. If you get yourself left in the process and you get yourself engaged in every step, then you design security in from the start. And then the testing at the end should be a confirmation that you did it right.
Yep. It's got to be hard to track, though, through the whole supply chain. There's thousands of parts in cars. Many come from suppliers all over the world. Even in the electronics alone, there's so many discrete components. How do you know that somebody isn't slipping something bad in somewhere in the supply chain? So even though your system looks brilliant and robust, somebody still could get in the other way.
Yeah. Actually, IHS has a service that are in the semiconductor component that are looking for that. It just become a big deal because some parts in the aerospace industry that happened to, and so they are now looking for that. And but I'm not sure the auto industry has started yet, but probably not yet, but somewhere, yeah.
I think this is a worldwide problem for every company. You know, supply chain security is a challenge that I think everybody is facing, and just understanding, I think you have to assess risk, right? You know, do good risk assessment to say what are the pain points in my design, and then have good security controls around those points from a supply chain perspective as well as every other perspective. But I don't know that the military has solved that problem completely yet. So, let alone the auto industry and consumer electronics industries.
But there's still the software and hardware and cybersecurity is going to be harder anyway, so they got enough with that.
Look, we're down to the end here. This has been a fascinating discussion. I think we're going to have to do part 2 at some point in the future, because clearly this is a field that's evolving. And I know I've picked up a little bit of the jargon myself of, you know, you got to sniff out the JTAGs and run some crypto through it. So there, see, I'm up to speed with you guys.
You're nailing it.
Anyway, I want to thank you all. Erika Anden from Silent Cyber, Jeff Massimilla from General Motors, Egil Juliussen from IHS Automotive. Great having 3 of you on here. Very important topic, and I'm so glad you shared your knowledge with us today.
Thank you.
Thank you.
I want to thank all of you for having tuned in.